Okay, so any questions about last class? We've been working through chapter 3. We spent a lot of time on conditional statements. So questions about conditional statements before we get back into chapter 3, before we start looking at our first proof, really start learning proofs. Any questions about last class?
Could you quickly go over like the antecedent statement, consequent statement?
Okay, all right. So Winston is asking about the antecedent statement versus the consequent statement.
Yeah.
Okay, and I'll put up that slide, the relevant slide as well. Let me see if we can get that going here. So every conditional statement is of this form. If circle, then square. And then what goes in for circle is called the antecedent, or the antecedent statement. What goes in for square is the consequent. This is symbolized circle, arrow, square. Circle, arrow, square. Whatever's, to make this grammatical, these have to be statements. They have to be statements, right? If whatever's in circle has to be a statement, whatever's in square has to be a statement. This is called the antecedent. This right here is called the consequent. Okay. So if I say, if it's raining, then it's wet outside. It's raining would be the antecedent. It's wet outside would be the consequent. And then I cashed it out in terms of, I said this, every antecedent is a sufficient condition for the consequent. And then every consequent is a necessary condition for the antecedent. I might as well complete this. A sufficient condition for the consequent. Yeah. So that's what we talked about last class. I think that's on the next slide. Yeah. The antecedent statement gives a sufficient condition for the consequent. Oh yeah. So don't forget, I haven't gone back to fix these slides. There's a typo here. The consequent statement gives the necessary condition for the antecedent. Okay. So Winston, is this the kind of question you had about it, or are you just reminded about it, or did you have another question related to this?
I just wanted to hear it again.
Remember what it is again. Okay. Okay. Yeah. Zoe.
So I'm a little, or not confused, I just want some more clarification about the sufficient part of it. So if it wasn't sufficient, it could be like, if dog, then it's a mammal. So like that would, like, if something is a dog, like, is a dog, does that make it sufficient for the first part of it?
Well, when you give it a conditional statement, you are stating that something is a sufficient condition. But you might be wrong. Like if I said something like, if it's an alligator, then it's a mammal. So I'd be wrong, right? But I'm still saying it's a sufficient condition.
Okay.
Does that answer your question?
I think so. I'm just wondering, like, when do you know if it's sufficient or not?
Oh, if it's in that place, if it's in that location, it's meant to be a sufficient condition.
Okay.
It's meant to be. I'm not saying in fact it is. Okay, so I'm going to be clear about that. It's giving a sufficient condition. It's offering a sufficient condition. But authors don't always get it right. Okay? Yeah. So that's interesting. Just like necessary condition 2 could be wrong. It's actually not a necessary condition. Yeah. Like, if he failed the class, let's see. No, if he didn't get credit for the class, then he, let's see, abandoned the class early. Well, that's not a necessary, let's see if that's going to work. Yeah, no, that doesn't work as a necessary condition because you don't need to abandon the class in order to fail a class. Does that make sense? So just because I assert something is a necessary condition doesn't make it a necessary condition. Just because I say something is a sufficient condition doesn't make it actually a sufficient condition. Okay. Other questions about this? So good. I'm glad you're raising that because I didn't mention that on the slides here, so it's good to ask that. Okay. The other thing too is make sure that these are full statements in these, right? I know you probably said it for sure. You said like if dog then mammal. So yeah, I know what you meant, but state it. If you're going to express a conditional statement, it's got to be statements here. If it's a dog, then it's a mammal. Yeah. Okay, so we're going to continue talking about conditional statements today, and we're actually it's going to be relevant, it's going to be used in our first proof. Okay. All right, so we did this. We talked about different ways to express this conditional statement. Number of different ways to do it right here. We went through this. And then there are many other ways as well. These are just some. Okay. All right. Then we symbolized this statement, this compound conditional statement. If there are zombies in the woods, so Z arrow stands for an if then, right? So if Z then, that's how you read that out. Then S and F. So what's S? You should not carry a sword. You should not only carry a sword, which means you should carry a sword and you should take fencing lessons. S and F. That's how to symbolize that. Questions about this? Okay. Keep practicing symbolizing. Go to the book, do the exercises, as many of the exercises as you can. Look up the answers online, stuff like that. Natasha.
Saying you should not, is that negation that you're just not going to say it because of the complicating it?
No, in this particular case, the not only is, yeah. Okay, this is a good lesson, and just because you see a not doesn't mean it's a negation.
Okay.
English is weird, right? So you should not only carry a sword. That's not a negation. It doesn't mean you shouldn't carry a sword. That means you should carry a sword and also something else, right? So when I was reading it out, I wasn't looking ahead. I was just like, you should not. And it's like, oh, is it a negation? And it's actually not a negation. It doesn't say you should not carry a sword. Natasha, so it's really important to look at the meaning of what's said instead of just looking for little words. Does that make sense? Because one word doesn't always mean the same thing. You can't just assume just because there's a not that it's a negation. Okay, so that's a good example of that. Marcus.
Is it because the not is, I guess, like doing operating on the word only?
Yes. So the operative, I guess, phrase would be not only. That's the operative phrase. It's not by itself. It's the not only, and then we can cash that out. What does that mean in English? So that's one reason the first couple weeks of logic is the toughest. I don't know if I said that yet, but I've kind of hinted at that. These first couple weeks are probably the toughest because we're actually dealing with the English language. And it's nuanced. And it sometimes is illogical. Because you think every time you see the word not, that points to a negation, but that's not true. Well, that's a negation, not. And I know students in logic often ask for kind of quick shortcuts, right? Like, hey, does that word always mean this? Does this word always mean this? Does this? And in reality, the answer is probably never in English. The book actually talks about even the if-then. Sometimes not actually a conditional statement. We're not going to really get into that. But it seems like there's always counterexamples in English in terms of the way the language is used, which makes it difficult. So we sometimes gloss over some of the things. We do look for some kind of patterns, but we have to be careful sometimes. The meaning, we use English in so many different ways that you can't just be looking for catchphrases and know what the answer is every single time. Okay. Zoe.
Kind of a quick question off of that. So if I were to go to Germany and try and study philosophy, would I have to start at ground zero because it's a different language?
Well, no, there's some shared grammatical issues, and also but the thing is, if you wrote in our symbolic language, it would be understood. Germans would understand it because that would be shared by them. However, when it comes to if German was not your native language or was your second or third, you would have some difficulty sometimes logically symbolizing it. Just like if English is not your first language, you're going to have, other things being equal, a more difficult time seeing the nuance and meaning and then therefore symbolizing it, as opposed to someone who is very fluent in English. Again, those are just general statements, but that's the hardest part of learning logic, is to go from your ordinary language, right, the natural language, and then symbolize it. But once it's symbolized, then we're all good to go. And that's when it's like, I can kind of relax a little bit. Because if that stuff is all clear, unambiguous, you know how to deal with that, then logic works well. It's these first few weeks when we're kind of transitioning from ordinary language to our symbolic, pretty much universal, symbolic language. Right, that's the tough part, I found, for students. I think I told you first homework assignment is maybe the most difficult homework assignment. And then if you keep with the class, the other homework assignments, in terms of knowing whether you got it right, it's much clearer. You're you know whether you got it right or wrong. The first homework assignment, you're not sure. Yeah, it's just, again, a generalization there, but that's what I found. Okay. But still, we kind of learn we do try to learn some patterns and some shortcuts in translations as well. We try to, because otherwise, it can be really slow and difficult. So we do try to look for that sort of thing. John.
I'm glad you're a couple minutes late, but you're showing how, in this instance, not is not necessarily a negation, correct?
Right.
If you would change the word should to would it change the negation?
Then you would not only carry a sword, but would also take. No, that would not be a negation. It would still be that not only it's pointing to more than one thing is true. That phrase not only would point to more than one thing is true. So if you change it to a would, yeah, it'd be symbolized. There would be no negation sign here. It'd still not be a negation.
Okay.
If you got rid of the only, then you have a negation, because it'd be you would not carry a sword, or you should not carry a sword. Those would be negations.
So if you got rid of the only?
But because if you got rid of that word only, then it would totally change the meaning. All right? It would totally change the meaning. By the way, that is an interesting translation thing. The word only is can be tricky, and it's kind of, if you know how to interpret the word only, that's kind of a test for your fluency in English. Because what you can do is move the word only all around this sentence and see how it changes the meaning. Like, for example, if I move the word only to the front, only if there are zombies in the woods, that's going to be translated differently than if it's just the word if. Move, you can test it out. Move that word only around and then try to re-symbolize it. It could change it pretty radically. Okay? We're not going to do that right here. We'll do it more later when we get better at symbolization. Okay? But that can test your your understanding of English language, but also helps you understand logic too. Natasha.
Well, I just had a question if there was like a symbol for things that are like if you were to say it's only this or like no exception type things.
Yeah.
Its own symbol.
Well, there's not an extra symbol for that.
Or how would you like clarify that?
Well, if we did, let's do all dogs are mammals. So we kind of know what that means, right? But if I did something like only dogs are mammals, I don't know if this answers your question, but you can definitely see a difference right there.
Yeah.
Right.
But how would you symbolize that?
How would you symbolize it? Well, we're going to symbolize this later. We're going to deal with that. Well, right now we're not really worried about. We're going to get to this later. Right now, the way we symbolize this is kind of too simplistic. Right now, we just symbolize this like a D. Okay. Only dogs are mammals. Let's focus on that. Yeah. Anybody want to try to symbolize this using the arrow? Using the if-then? This is actually jumping ahead a little bit. Okay. So you might not be able to do this yet, but maybe some of you are able to. Only dogs are mammals. How would you symbolize that?
Would you put that in parentheses? Or would that
You wouldn't need a parentheses for this.
Yeah, that would
This would be circle, arrow, square, right? But what goes in circle, what goes in square? Yeah.
Is it M arrow D?
M arrow D. So what does M stand for?
Mount.
Well, you would say mammals, if mammals, then dogs. So do it in English, like, what does M stand for as a statement? Make it a statement. If something's a mammal.
Yeah.
So that would be a statement. If something's a mammal, then it's a dog. Is that what this says? Only dogs are mammals. Okay, Paige?
Just be D, arrow M, then.
Okay, if it's D arrow M, then it's saying if it's a dog, then it's a mammal. Is that saying the same thing as only dogs are mammals? That's not saying the same thing, so this doesn't work. D arrow M. Okay, Marcus?
Would it be biconditional? So like M and then biconditional.
Well, biconditional would mean something's a mammal if and only if it's a dog. Okay? No, it doesn't. That's not what this says. What's wrong with this one? I still haven't seen what's wrong with this one. If something's a mammal, then it's a dog. Only dogs are mammals. Hey,
You say if and only if it's a dog, it's a mammal.
that's saying more than this, isn't it?
So is
Saying
that,
all mammals are dogs.
Well,
Yeah. This is basically saying all mammals are dogs.
yeah.
All mammals are dogs. It's connected to it. I mean, it's not bad, the if and only if, but I think you're reading into it, you're reading more into it. all this is saying is that the only mammals you'll find are dogs. Only dogs are mammals. So it's saying, okay, at minimum that being a dog is a necessary condition for being a mammal. If it's a mammal, it's a dog. Okay? But you're going to learn how to do this better. So this would be a more accurate way of doing it. But don't worry about this too much, because later chapters will get into this and we'll get better at symbolization. I'm going to keep you working on symbolization through the class, through the course. So a number of assignments, homework assignments, are going to ask you to symbolize. You're going to just get better and better at it. Okay. But this shows me this little exercise, Natasha's question, has told us that there's still unclarity about how to symbolize in logic. Okay. All right. Yeah. Only dogs are mammals. This one. Okay. Again, don't worry about it too much if you don't quite see that yet. You don't quite see that. Okay. We are going to learn our first, what's called rule of inference. Let me back up a little bit. To do proofs in logic, actually proofs in any kind of discipline, you need rules that allow you to proceed in a proof, that allows you to go from step to step. We're ultimately going to learn, approximately 15 rules, and a few more than that. Not too many, probably all told under 20. This is going to be our first one, and we're not going to learn all the rules at once. The way the book sets it up is that you learn rules as you need them, and then by the end, you're going to have the rules covered. And I think that's a better way of going than just shoving into your lap like a ton of rules, right? Or the 20 and memorize them. No, we'll learn them as we need them. Okay? So our first rule is called Modus Ponens. It is a very famous rule. Long history. It's sometimes called the mode of affirming the antecedent. So Winston asked about antecedent and consequent. Modus ponens is a rule where you begin with a conditional statement, any conditional statement, and then you affirm. In other words, you say it's true. So affirm it is to say it's true. And in the case of modus ponens, what you affirm is the antecedent of that condition. So take any conditional statement, circle, arrow, square. You affirm the antecedent. In other words, you say the antecedent is true. Then it logically follows that the consequent is true. The book expresses it this way: if P then Q, P therefore Q. But it's the same idea. And again, this expresses the form of this rule of inference, and it's an argument form, and we're calling it a rule of inference because it's an argument form that's always valid, and it's very, very useful. So we're going to use it as a rule. Later in the class, we're going to actually prove that it's valid. Right now, we're just like, it's intuitively valid, right? Intuitively makes sense. Okay? If I was born in Goleta, then I was born in California. I was born in Goleta, therefore, I was born in California. That's how that works. If it's raining, then it's wet. It is raining, therefore it's wet. Winston.
The little dots that make a triangle, is that Modus?
No, the little dots, I think I did this a little while ago. That's just a symbol for therefore. Okay? So you have, every time in Modus Ponens you have these two, you call them premises, or lines. Okay. Then you can infer, you can conclude a third line, a third statement. So these are statements, then you have a third statement that can be inferred or concluded from these two. Circle, arrow, square, and circle. The reason square follows is that circle is a sufficient condition. It means it's enough to get you to square. So this way of thinking, this pattern of reasoning, is always valid. So you can use it in a proof. Marcus?
So if the circle was a compound statement, would you need an individual premise to affirm each part of the antecedent, or would you be able to just say A and B, for example?
I think I have some slides answering your question, and let me see if I understand your question. So, you have circle, arrow, square, and then you have circle, and then you can infer, right, or conclude square. So, what goes in here is going to be a statement. Okay. Just like here and here. Okay. So you're going to have a statement in each of these. But the statement doesn't need to be simple. Okay? The statement itself could be compound. It could be something like L and S. Could go in there. That's one reason I like to use circles and squares, these geometrical figures, when I talk about argument forms, rather than capital P's and Q's. Because by doing it this way, it can be confusing, because often the book uses P's and Q's or capital letters to refer to specific statements, individual statements, right? Like, if porcupines are cuddly. So that's a specific statement about the world. But now, in here, what you're saying is, you're talking about argument form, where this doesn't have specific content. So it's confusing. It's like, are you talking about specific content or not? So here I like to use circles and squares because I'm not giving you content there. You plug the content in, and the content could be extremely simple or it could be extremely complex. As long as it's a statement, but it could be a compound statement. Did I answer your question?
Yeah, so it's sufficient enough to say in one premise, L and S, just state it naturally. Or do you need two premises to say L, and then another premise to say S, and then
You don't need, yeah, you don't need that. You can do L and S.
Okay.
So you can have, what goes in here could be L and S. And then over here could be Z or T. Then, what goes right here? L and S. Whatever's in here, got to go in here. Okay? And then here, what goes in there for modus ponens? Z or T. Don't mess around. It's not anything else. It's Z or T. Okay. I always debate whether I should do this or not. I have a. Oh yeah, the lighting. I usually try to do the AV mode. Let me do the AV mode. I have a cheesy. Well, I don't know if it's cheesy. I have a cheesy folktale. To make this point, should I do it? Do you want a folktale or move on? I can say it quickly. Let's do a cheesy folktale. Oh, maybe I don't know if it's cheesy. Okay. So here's a folktale. A Siberian folktale. Okay. All right. So this kid is playing in the snow. It's Siberia. It's always snowing. So this kid is playing in the snow, and he's having fun and stuff. But it's getting late. It's getting kind of blizzardy and stuff. And he's called in to dinner. Okay, come inside, Junior, whatever, or Sasha, or whatever. And it's getting stormy, that kind of thing. Come inside. So he starts coming inside. He's wearing mittens, but he's rushing to get inside. He drops one of the mittens. Okay. Well, that's a pretty big mitten. Let me. He's not that big of a kid. So let's see, like this. So he drops one of the mittens in the snow. Okay. So there it is. All right. So he goes into the house. All right. There's a mitten out there in this Siberian blizzard. A little bit later, a vole comes walking by. It's cold out. You know what a vole is? You've seen, yeah. There are actually voles around here. It's like a Siberian mouse. Okay, but there are voles around here too. Anyways, the vole crawls into the mitten, nice and cozy. Cool. Okay, a little bit later, a rabbit comes walking by. Rabbit's cold. Rabbit looks in and goes, "Whoa, can I join you, vole?" And the vole goes, "Yeah, I think you can fit." So the rabbit goes into the mitten too, and the mitten accommodates the rabbit. You know, it's knitted really well. Okay, it stretches to fit the rabbit. A little bit later on, a fox comes. Fox too is cold. It wants to go in, and then the vole and the rabbit say, "Yeah, hey, you can join us." And the mitten stretches and fits the fox. See how this is going? Eventually, it winds up a bear comes in. Okay, and it's Siberia, so of course a bear is around, right? Bear fits in there. Okay, but the mitten accommodates the bear. Okay. And then in the morning, they all scatter and leave. Of course, the kid comes out again, gets the mitten. Now it's a little bit stretched out, but it still works. Okay, cheesy folktale to make a point. This is so cheesy. That these forms, when we do rules of inference, these argument forms, right? They're stretchy like mittens. This is goofy. Okay, they're stretchy like these Siberian mittens. Okay, so you can put an L and S. You can put in. You can put an L and S, arrow, Z or T, double arrow, L arrow, not S, etc. Anything you want, and as long as it's a statement, okay, you can fill that in there. It can accommodate anything. All right, but whatever's in here in the circle for the modus ponens to work has got to also be right there. So whatever this is has got to occur there exactly. Okay? So let's go back to folktale. If there's a bear in here, there's got to be a bear right there. Make sense? Okay. So hopefully that didn't take up too much time. Okay. So yeah, you're gonna see this. I think I have a slide or two that kind of does this. That kind of makes sense? Okay. That was a long-winded answer to your question, Marcus. Okay, so what we're gonna do, and then we're gonna do some stretch. It's gonna get stretchy a little bit. Let's do some proofs using modus ponens. Okay. What we're gonna do is that first of all, we're gonna symbolize this argument, and we're gonna prove it to be valid. We're gonna prove it to be valid. Okay. Premise 1, if there are zombies in the woods, you should carry a sword. Premise 2, if you should carry a sword, then you should take fencing lessons. Premise 3, there are zombies in the woods. Therefore, you should take fencing lessons. And so what I've created right here is a dictionary, so-called dictionary, with Z, S, and F. Z, that statement letter, is going to stand for the statement, there are zombies in the woods. S is going to stand for the statement, you should carry a sword. F is going to stand for the statement, you should take fencing lessons. Now you could start symbolizing that proof, that argument, on its own. Well, I guess technically this isn't a proof yet. It's an argument. We're going to prove it to be valid. So, argument. Now the next step is to symbolize that argument, okay, given this dictionary. Or at least symbolize the premises. Symbolize the premises, then we're going to prove it. Anybody call it out? Number 1. How would you symbolize that premise? Just call it out. Hunter.
Z arrow S.
Z arrow S. Good. Z arrow S. It'll be on the next slide, but right now I'll just kind of just speak them. John.
Shouldn't it be if Z?
The if, we are symbolizing now. The if is dropped out. The arrow accommodates it. The arrow accommodates it. If you say Z arrow S, that includes the if. The arrow means if Z, then S.
But I thought Z was there are.
Yes, if there are zombies in the woods.
Right, but to me it's different if there are and there are.
Wait.
If is
You're not saying there are zombies in the woods until premise 3.
no, but I'm saying in the blue.
Yeah, but I'm not saying, okay, if I
Once
say,
you put that down, it means that.
no, it does not. No, it means if there are zombies in the woods, then you should carry a sword. That's what it means. This is circle, this is square. Okay? So if the circle is by itself, yes, you're saying there are zombies in the woods. But because it's in a conditional statement, you're not. It's part of the conditional statement. You're actually not saying there are zombies in the woods yet.
Because of the form, you're saying.
Yeah, because of the form. It's
Okay.
the conditional
I
statement.
got it.
Okay? Let's symbolize number 2. If is not part of our symbolic language. We've got rid of it. It's covered by the arrow. Natasha. S0, wait, S arrow F. Yes. S arrow F. Now, the third premise, now you're saying Z is true. And by saying that, you're saying there are zombies in the woods. Now you're saying it. You're saying it to be true. So premise 3 is just Z on its own. So that's the first thing you do in a proof. I'm giving you that this is the start of the proof. And let me read it out to you, tell you what this means. You number each of the lines in a proof. Premise 1. You begin by listing the premises. That's what prem stands for. Prem stands for premise, right? So, premise 1, Z arrow S. Premise 2, S arrow F. Premise 3, Z. And this is something the book does not do, but I like to do it. And that's tell the reader what the conclusion is. The conclusion of the argument is, let's go back to the previous slide. You should take fencing lessons. That is F. That is the conclusion. Okay. So, this is how we begin our formal proof. We list all the premises of the argument first. Then, I think it's a good habit to put down call it the target. This is what you're trying to prove. F is true. In other words, that's the conclusion. Tell the reader and yourself that's what you're aiming for. F. Then the next thing to do is complete the proof using our rules of inference. Okay? To get you to that target, to that conclusion. That's how proofs work. That's how proofs work. This is just the start of it, though. We haven't finished the proof yet. But any questions or comments about this setup here? Hunter.
To make this simpler, couldn't you almost say Z arrow F? That will follow. We can generate that from another rule of inference, which you haven't learned yet. But what you do not want to do is skip steps like that, because it can confuse a reader. Don't start combining premises in the start of your proof. The best way to start a proof is to give each of the premises in the argument its own line. If you start combining things logically, you're going to lose your reader in many cases. Don't rush. There's no reason to rush. Okay? Sometimes you're going to want to rush, you're going to want to jump ahead, because you're like, I see how logical it is, blah, 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 and you just want to go ahead. But proofs force you to slow down and do it step by step. Actually, it kind of helps you write essays. Personally, I had a problem writing essays for years because I didn't want to do what I call the dirty work. And that is step by step, careful, move by move. Tell the reader where make everything transparent to the reader. Do it step by step, incrementally. I wanted to skip ahead. That is not good writing. It's also not a good way of doing logical proof. Okay? All right, best essays, step by step. So they bring the reader in, right? They never lose the reader. It's really important not to lose the reader. If you go too fast like you just did, then the reader has to read your mind, what you did logically. And they might not see it. Some might, not all will. Okay? John.
In the yellow, what's that diagonal line?
Oh, that's just a slash. And then the therefore, the 3 dots, which means a therefore. This is just notation that I use, you don't have to use it, to tell the reader this is what I'm seeking,
this is my conclusion. So, slash, therefore, F. You could do other things to do later, to, that, or you could just skip this part. But when I teach proof and when I do proofs myself, especially when they get really complex, it's always really good to know exactly what the target is at every point. So again, it's a kind of a teaching pedagogical device that I actually wish the book used, because sometimes in the book you're like, what were you even trying to see? And you have to go back and figure that out. Okay, just trying to make it really transparent to the reader what's going on.
Why wouldn't you have a fourth premise that just says therefore F?
There's only 3 premises, that's why.
Or
Go back to
I
it.
just like the fourth line.
Don't do a 4th line yet. There will be a 4th line. Okay? Because what the proof does is fill in the logical steps to go from the premises to the conclusion. It's not a one-step move. That's what we're doing. So we have an argument here, but the argument doesn't give you all the logical maneuverings. What we're going to do in a proof is fill in the logic. Make it transparent to the reader. Because maybe they don't see that it's valid. And so you're going to prove that it's valid by filling in the steps to get here. So this might not actually be line 4. It might be line 6 in the logical world. Okay? In English, we often, or whatever your ordinary language is, your natural language, you often take shortcuts. There's a shortcut here logically to get here. So what we're going to do is spell it out. How did we get there? That's what a proof does. It spells out the logic of the argument that was given. Spells it out and makes it obvious that the argument is valid. So that's the purpose of a proof. Cool? Good questions. Anything else going on? So this is how we begin our formal proof. John.
Could you, write out the next line, like you did, there?
Wait, here?
Yeah, cause see, I think it would be S, therefore F, but, no, just like you had it there. Can you write out the second line, what it would look like, in terms of squares and circles?
Oh, I see. Oh.
Because I was wondering if the second S would be in a circle or a square.
Okay. It depends what rule you're using. So the way I use circles and squares is not to give everything a circle and square right away. You only use it when you're manifesting a rule of inference, because it'll turn out that. Actually, I'm going to answer your question. Just wait for it.
Okay.
Wait for it. Hunter actually wanted to replace this with 0 F. But then that actually is this. Circle, arrow, square, square, arrow, triangle, square, arrow, triangle. So we'll get to that. But we're not doing that today. We're not doing that. So in that case, they both would be square. But we're not going to do it that way today. That's an extra rule. We'll learn that rule. Okay? We don't want to learn too many rules too fast. At least that's not the way the book teaches it. That's not the way I like to teach it too. Okay. Right now, you only have one rule to use. I'm constraining you. You only have one rule you can use. That means only one way to generate new lines in a proof. Okay? That rule is Modus Ponens. That rule, again, looks like this. Okay. So the question is, given the premises, do you see this pattern emerging? Do you see this pattern there? Do you see modus ponens? At least the first two parts. I see some nodding. Yes. Which lines? You know what I'm asking? Where do you see modus ponens here? 1 and 2. Well, if it's 1 and 2, that would be circle, arrow, square, and then I guess it would be square, arrow, triangle. But that's not this.
It's 1 and 3.
1 and 3. So imagine you superimpose the circles and squares. Another reason I use circles and squares is you can actually superimpose it on the proof itself. Z, arrow, S, Z. If you, so how these rules of inference work is this. If you see, okay, these two lines in the proof anywhere, then you can generate or derive a new line based on those two. So if you have circle, arrow, square, and circle, which you do, you can derive square. And what's square? S. So that means on line 4, you can put down S. You've generated a new line. You've created a new line combining, okay, previous lines. That's how proofs work. Use earlier material to create new material. And there's a lot of metaphors you can use. It's like cooking. If you have ingredients, you can combine those ingredients in different ways to create new things, which then you could then use for other. Whoa, it's like that. Okay. So line 4. Let's see if I have it on the next slide. I'm giving you the full one. Okay. I might as well give you the full one, then I can talk through it. So line 4, you derive S. So I'm going to write it here. So line 1, you have Z, arrow, S. Line 2, you have S, arrow, F. Line 3, you have Z. Now, using modus ponens on lines 1 and 3. See, that's what I did there. We used modus ponens. That's what NP stands for. On lines 1 and 3, this is how that proof works. We derived S. Circle, arrow, square, circle, therefore square. Now, we have a new line we generated. Given, so you used to have, I guess you could say, 3 ingredients. Now you have 4. And you can reuse lines however many times you want, too. Now, modus ponens occurs again. Look, circle, arrow, square, circle. So that answers John's question a little bit, right? Now S is functioning as circle. We're kind of starting anew here. It's like we started with 3 lines and we generated something new. Now let's go look at everything again with a new eye. What can we see? Now we see circle, arrow, square, circle. So you can derive square, which is F. And then you write down what rule you used. Well, you use the same rule. And then you tell the reader which lines it applied to. 2 and 4. John.
Hopefully this is not annoying, but the way I see things, like, so in the first line, you have Z, circle, Z, arrow, square, S. would you have to prove that square S and circle S are the same? Or that's just considered a given? Like in other words, in a formal proof, would we have to prove those are the same things? Is using different symbols for the S's?
Wait, I'm not using different symbols for the S's.
No, I'm saying in the first line, S is a square.
Okay, wait. But circle and square is not part of the proof.
I thought that is.
It's not part of the proof. Nope. No. Look, there's no circles and squares here. So let me back up. The reason I use circles and squares is purely
Okay.
pedagogical device, a heuristic device to get a proof done. It's useful. It's like, what I'm doing here is kind of giving a spatial representation for what's happening logically. I'm spatially representing with the circles and squares. I'm giving a pattern for logical reasoning of modus ponens.
Okay, well, then if you did use those as part of the proof, would you have to prove square S is equal to circle S? Or?
Yeah, but we're not, so that's good. We're not gonna, no.
I thought it was part of it, I'm sorry.
It's not part of it. It's, if you look at the answer here, the proof, there's no circles and squares right there. It's just what I'm doing when I do a proof, and what you'll probably be doing too. You'll be superimposing patterns. You'll be seeing patterns. Okay? Otherwise, if you can't see patterns of these logical patterns, and this is just one way of doing it. You could see them in different ways, right? This is one way of doing it. Then it's hard to see when to use modus ponens or using all the other rules of inference. The rules of inference can be understood as patterns of reasoning. So what I'm doing is superimposing those patterns on the proof itself. And you might not need it here. It's because it's such a simple argument. But when it comes to complex arguments with compound statements, if you don't see the patterns, then the proof can be extremely hard to do. And so this is just one way of like, in a way, kind of distilling the essence, the logical essence of these arguments, or to, again, starting to say other ways of seeing the patterns of thinking. This is a pattern of thinking here: circle, arrow, square, circle. That's the way I'm talking about patterns of thinking, kind of in a spatial way. Let's see. Okay. But these drop out. These are just kind of useful devices. If you don't want to use them, you don't have to. It's kind of a teaching device, but also I use it to do proofs too, like in reality, but I don't leave them really. That's not part of the proof. Okay. So now you're at F. But wait. That was our target. That was our conclusion. So our proof is done. What you want to do in a proof is put your conclusion, your target, on the last line, and proof is done. Natasha.
I just had a question with the last one. So every time you like add a line, you look at like the totality of the line? Like,
Well,
you went to 5, you had to include 4. So you'd like stop and relook at your whole thing every time?
well, yeah.
It's not
If the
just
proof
based on-
wasn't finished, if it's keeping on going, then you can always just go back and reuse any of these things. Okay?
Okay.
Now there are exceptions later on which we'll learn. Sometimes previous lines can't be used again. But when you first learn how to prove, you can reuse, and the more lines you generate, the more you have to work with, which is super handy. Okay, you're generating new things, but you can use all the old stuff too. And so you have more and more and more and more. You just generate. Okay? And what you're trying, but it's not aimless generation, right? You're aiming for a target, and once you get that target, then the proof ends. Once you've achieved that target. This is your first proof. How are you with that? If you understand this, you're in good shape, and it's good you came today, you're good, right? Because sometimes learning proofs, the first day is the most important. It's hard to like jump into this later. So again, learning this stuff step by step, and at some point you go like, yeah, I get this. Don't be too frustrated if you don't quite get it yet. You don't quite get it yet. We'll do more of them. Winston.
I was just wondering if I have it right. Like, so for when you have like the premise like that, but like the one reading of the Modus Ponens,
Yeah.
that's just explaining that you got it from like we got it from 1 and 3, and then that's why you could get 4.
Yes. Yes. This is kind of like the justification
Yeah.
for this.
Like,
So you have the result right here, and then over here you go, this is the justification for that result. This is why you were allowed to get this. Okay. Marcus.
So on our homework, for the proof questions, it just starts with a couple of premises, and we're just supposed to say.
Just finish it.
Yeah, okay.
Just finish it until you achieve that conclusion. Yeah. Yeah. Winston.
So I haven't read it, but you don't want us to just go to the third one. You want us to do 4 and 5, right?
What do you mean to go to the
Or
third one?
like you want us to do the full steps like that.
Well, you notice here you can't just skip this one. Why?
Yeah.
Because the fifth one relies on 4.
Yeah.
If you didn't have 4, you couldn't get this. You have to go through that step. See, that's filling in the missing logical steps. There's only one. Right. But we needed that to make it work. And we're assuming modus ponens is valid and stuff, or it's just intuitively the case. That kind of. All right. We should do another proof, right? Let's see. Oh, this is kind of useful. I did actually annotate this proof a little bit with arrows. So premise, 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 premise. What we want to prove. It's right there. MP, it's just abbreviated way of expressing what rule of inference we're using. Modus ponens. And then over here, the numbers of the lines to which the rule of inference applies. Or the lines, which you use the rule of inference on. Have you looked at that for a second? Okay. Questions about this before we go on? I'm actually going to let's do a proof. Let's do, we can try to do some from the book. Okay. And each of these proofs will, bring in another feature. Instead of writing prem, I'm just going to do PR for premise, just to save some ink, I guess. And our target is going to be C. So I'm going to read off these premises. Premise 1, A. Premise 2, A arrow, B arrow, C. 3 is B. And then the conclusion is C by itself. So we have one rule of inference that you're allowed to use. Only one. Again, that's called MP. And I'm going to write down its form. What you want to do is memorize the rules of inference. So you want to memorize the forms. So this is the first form you should try to memorize. Okay. Since there's only one rule of inference, then that's all you're looking for. Instances of modus ponens, or how you can use modus ponens given the lines you have in your proof. Okay? So starting this proof, given these 3 lines, 1, 2, and 3, can we apply modus ponens? Can you see how modus ponens could be applied to this proof? And call it out. Which lines can modus ponens apply to?
2 and 3.
2 and 3. Okay, so Paige, specifically, what would go, if it's 2 and 3, what would go in for circle?
It would be B, because it's A equals B. Right?
Okay. Okay. This is a good example to bring up this issue. It's tempting to do that. It's tempting to see modus ponens with B arrow C and B. Okay? But that would be a misapplication of modus ponens. Because if we're going to use forms, the form of 2 and 3 is actually, if you think about it, would be something like circle, and I guess this would be square. But if this is square, then this would be square arrow triangle. So now you have circle arrow, square arrow, triangle, and square. That's not the same as this. In other words, modus ponens applies to a conditional statement of this form. The whole line has to be this. And what you were doing is you were ignoring this part. You cannot ignore this part to make modus ponens work. Okay, there's some other hands up. Go for it.
Would it be 2 and 1? So it says circle would be A, square would be B, arrow C, and then when it says circle is A on the second one, then it would be B, arrow C.
Okay, yes. Okay, so then that would be a proper use of modus ponens. So A, arrow, I should have made this bigger. But these are stretching, remember. B, arrow, C, and then A. Now, you may not have seen this. This raises another issue. Because it's not in the same order. But logically, that doesn't matter. Logically, it doesn't matter. These 2 can go in a different order. Okay? So these are patterns. Okay? But they're not patterns like, I don't know if this metaphor, this analogy works. They're not patterns like guitar chords. See, guitar chords are patterns of fingering, but you can't just switch your fingers. You can't just switch strings. Right? In logical patterns, you can switch the order of the premises here. Now you can't take the conclusion and put that up at the start. But these two you can switch the order. So it's good that you saw that. Alright? So what you get is circle, arrow, square, and then circle. Circle doesn't have to be after. Okay? So there's a couple lessons here to be learned. Modus Ponens applies to whole lines, not to parts of lines. Whole lines. It's really important to do that. Whole lines. And it doesn't matter the order. So, what that means is that on line 4, you can infer B arrow C. That is square. So I'm going to pause there. Does that make sense? Let me look at the time. Okay. Oh man. What was your name again? Jazeel. Okay, thanks. Jazeel. So Jazeel, what numbers here and what? Oh, the rule of inference would be NP. That's the only one we have. So then you said 1 and 2. I think the book does something like 2 and 1 or something. I don't care. Whatever order you want. I do it numerically. I always do. I can never mess around like changing the order there. So the book I think does it 2 and 1. It's the same idea. So now we have B arrow C. Our target is C. Can you see how to get C? Yeah, Natasha?
Do you use 3 and 4?
Exactly. 3 and 4. So that's circle, arrow, square, circle, so you get square, which is C, and P. Proof is done. You got the target. How's it going? Going okay? Let's see, what time do we have? We have like 4 minutes. Let's do, I'm just gonna maybe just show something without a proof from the book, but just show something here. So say on line 1, let's just do something here. If you have not, let's see. Let's keep, I don't want to get too complicated. You have not T, arrow, not S. Let's do that. Just a little thing. Line 2, let's say we have not T. I just want to make sure that you understand that modus ponens can apply to 1 and 2. Make sure you see that. Because this is circle, this is square. Remember, anything can go in for circle and square. You have circle here, so therefore you can derive not S. Just want to be clear about that. Emberly.
I have a question about one of the ones on the homework where there's it says one of the premises is not F. Would I have to show F and make a new line as F or?
Depends on what you're trying to do with it. Okay.
Do I have to show that not F is equal to F?
Depends on the proof. Right now we haven't even learned that rule yet. Okay. But let's just show really quickly another one. So we'll get to that next class. We can, we'll talk about that. Let me just do something really quickly here. Maybe combine a couple of different issues. If you have this, and then on the next line you have not, Z, and S, that too is an instance of modus ponens. Because this whole thing can be in circle and this is in square. Or I should say oval and rectangle, whatever. You get the point though. These are stretchy here. And so now you have circle, so you can derive not you. That's square. Okay?
Can we do one, sorry, can we do one that's switched up like last time? I think that's what was,
What do you mean switched up? The order is different?
yeah, out of order,
Well,
less simple.
okay. So if you have something like not S or T, line 2, let's say you have not S or T, arrow, not you. Okay, let's do 3 negations. Okay. Line 3, you can derive not you, because this is circle, arrow, square, and circle. See that? And so that's square, and so you heard 1, 2, and P. Just like here would be 1, 2, and P. These are just different variations. Cool. And of course, every time you add another rule of inference, you can do way more. Right now we just have one rule of inference. Only one rule. So you can't do too much. Might look like a lot, but we're only doing one rule. So. Okay, I think that's enough for today. Learning proof system, starting there. We're going to get to chapter 5 next time. There's something I want to do too. I want to talk a little bit, I haven't talked too much about it, a little more about symbolization. Remind me if I forget to talk about that. The grammar of our symbolic system, because that's going to help with homework too. All right? Have a good weekend. I will see you